Thank you. Okay, a coefficient, guys, is the number in front of the variable. And some of us still didn't know this yesterday when we were doing it. Coefficient means the number in front of the variable, not the variable, not the variable. So the coefficient is the number in front of the variable. So looking at this, for example, we're going to name the coefficients really quick. 2x cubed minus 4x squared minus x plus 2. Coefficients are the numbers in front of the variable. So what's the coefficient in front of x cubed? 2. What's the coefficient in front of x squared? -4. And what's the coefficient in front of x, guys? Good. -1. You're awesome. And then what's my constant coefficient? Good. That's a constant number. So it's still called the constant coefficient. And a lot of times, you're right, it's 2. And a lot of times, guys, they'll give you something like this on the ACT, and they'll say, name the constant coefficient, just to see if you know what they're talking about. So in this case, it would have been 2. Does that make sense, everybody? Just make sure before you do that on a test or something, you've looked and combined all like terms. Okay? Does that make sense? So if we had 2 plus 5, you would have combined them and then said the constant coefficient. Is everybody okay with that? Pretty basic stuff right there. Okay. So let's look at our first examples. We'll get right into it today. I'll let you start practicing right away here. So determine the degree, the number of roots, the number of terms, and the coefficients of this polynomial. Once again, we're going to go through. We're going to determine the degree, the number of roots, the number of terms, and the coefficients in this polynomial. First of all, is it in standard form? Yes, it's in standard form. Highest degree, the next highest degree, the next. Okay, so have we combined all like terms in this? Yes, there's nothing else we can combine, so we can begin. So first of all, what is the degree? 5. You go off of the highest degree, so this is degree 5. Questions on that? Make sense? Okay. Well, if that's true, guys, if that's true, how many roots, how many answers, how many zeros does this polynomial have? 5. Good. That's called the fundamental theorem of algebra. You know this has 5 roots, 5 answers, if you solved it, because of the highest degree. Very good. How many terms does this one have? Terms, guys, separated by plus and minus signs. How many terms? 3. 1, 2, 3 terms. Good. And then let's name all of our coefficients here. -3, -2, and +5. What's my constant coefficient? 5. Okay, just asking. Okay, pretty easy. Let's do one a little bit. That takes a little bit more than set you free to work. So it says determine the degree, the number of roots, same thing we did in the last one, the number of terms, and the coefficients. So this one is 5 times x minus 2 times x plus 4. Now, we've got to actually go through and think about this one before we can go degree, roots, terms, and coefficients easily like the other one. I prefer to just multiply it out instead of try to make guesses and do it in my head. That's just me, though. But I really think most of you will need to multiply this out. So looking at this, it would be hard to determine, okay, the degree is not so bad. What's the degree of this one? 2. It is 2. But let's say you didn't know that. Let's just go ahead and multiply this out. And I'm going to caution you on this one. 5 times x minus 2 times x plus 4. You've got to multiply all those things. If you're ever multiplying 3 things, guys, the key is to focus on 2 of them, multiply them together, combine all like terms, and then multiply the third thing in. So I'm going to focus on this piece right here and just multiply that out and not forget the 5 later. I'll multiply the 5 in. So we have to double distribute here. X times x, x squared, x times +4, +4x, so plus 4x, and then -2 times x, minus 2x, good, and then -2 times +4. -8. Let's combine all like terms. So I have x squared, no other x squareds. Took care of that. 4x's minus 2x's is how many x's? Good, 2x's, so plus 2x's. Just took care of those. And I still have my -8. Now I won't forget, it would be a tragedy to forget that ding, 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 5. So we've got to multiply 5 to all that stuff. 5 to all of it. It wasn't just 5 multiplied to part of it, it was 5 times all that stuff. 5 times x squared. 5x squared, 5 times +2x, plus 10x, you're awesome. Keep going with me, guys. 5 times -8. -40. And we'll combine all like terms. Oops, I forgot to write squared. Combine all like terms. And we're done, right? No like terms there. So, okay, now we can go through and say the degree. degree was 2, which makes sense, guys. We would have had 2 roots in this one. 2 roots. So, okay. Degree 2, thus we have 2 answers, right? So 2 roots. The number of terms, how many terms? 3, 1, 2, and 3 terms. And then what are my coefficients? 5, 10, and negative 40. What is the coefficient in front of x? 10. Good. Okay, good. Just testing you. Questions on that? Okay, practice it on your own. Ready, set, go. Practice it on your own. You can work with the people around you. That doesn't mean, no, you're not moving, right? We're all working with people around us. We're all friends here. Okay, next matters of business, guys. You have to come back to me. Even if you want to keep working on that worksheet, you will be lost on this next stuff, okay? Pull yourself away or I can't hand out the worksheet until the end of class, okay? So now what we're going to do, guys, is we're going to be given 2 functions and we're going to find where they intersect. So given 2 functions, we're going to find where they intersect. So given f of x is equal to x minus 5 and g of x is equal to x minus 3 squared minus 25. We're given these 2 different functions. We want to find where they intersect. Now, I had to draw this last night on not the smartboard, but with my little, like, just a mouse with my hand, and so that's why it's all squiggly. But just, it's fine, right? It's the idea that counts. So what I want you to think about, guys, is I just graphed these 2 functions. I graphed f of x, this green thing here. It's a green line. Does everybody see that? And then on my calculator, I graphed g of x and as well in the same window, and it looks like this. It's a parabola. Now notice, guys, where they intersect is right here and right there. Does everybody see that? That's where they intersect. Now think about it, guys. That's where our functions are equal. True? That's where they hit each other. They're equal at that value. Very good. So we're going to have a point right here where they were equal and a point right here where they were equal, where they intersected. Now, you could do this by algebra. You could say, okay, so x minus 5, you could go x minus 5 is equal to x minus 3 squared minus 25. One way of doing it is this, and then solving for x piece by piece. Or you could use your calculator, okay? Or you could use your calculator. So I'm going to opt for the calculator on some of these. How about you? Yeah? All right, guys, so get out your calculator so we can quickly learn this. Here we go. Follow me through this, because if not, you're not going to know how to do it. And it kind of seemed like the other day, some people didn't follow me through it, and then they were like, I don't even know how to do this on my calculator. Okay, so pulling up your calculator, guys, this is what you'll do. Go to the y equals button. Okay, so you'll go to y equals and clear out anything you have in there. Is everybody there? So now in y1, we're going to type in our first function. It doesn't matter the order that you type it in. So the first function was x minus 5, right? So type in x minus 5. X, and you can't type in, look, this is important, guys. You can't type in x negative 5. You got to type in x, and then the minus sign, minus 5. Now scroll down with your arrow. y2, now look at my, if I was to hit graph, that would graph my line. Over here you can see it mine in multiple views here. So now I'm going to also graph on the same window. I'm going to graph the other function, which is x minus 3 squared minus 25. Parentheses matter, guys, so make sure you use them. So x minus 3, you can't type in negative 3, x minus 3, close my parentheses, and then squared, and then minus 25. Okay, now I hit graph. Is everybody there? Okay, so I hit graph. Now in my window happens to be okay. I can see, guys, look, I can see where they intersect. So that's good enough for me. I don't need to make my window bigger. It's up to you, though. But there are going to be times when you have to make your window bigger, okay? So notice these are intersecting in 2 places. Now this is how you'll do it, guys. We want to know where they intersect. So you hit second, the second key, second, and then trace. Right here's the trace button. Second trace. Now notice it says value, 0, minimum, maximum, intersect. So you're going to scroll down to intersection. Is everybody following me? Okay. I hit enter. Now it says first curve. So it just means what equation do you want to be your first equation. So I'm just going to, now notice, look, right here's my little circle. It's on the line. I'm making sure it's on the line. Does everybody see that? Okay, it's on the line. I hit enter. That's my first function. Now it says second curve. Now it will automatically go to the other function that was close to that. That's the other function, not the one you just chose. So it's automatically going to do the right one for you. Does that make sense? So second curve, you can just hit enter. It knows, your calculator knows, she chose the first one. He or she chose the first one. I need to go to the second function. So now just hit enter again, and then hit enter. It says, you want me to guess? Well, we do. And then we hit enter again. So our intersection is that x is equal to negative 1.32, y is equal to negative 6.32. So our intersection is at that point. So I'm going to write down that point really quick up here. So this one was at the point negative 1.32 on x, and then y, it was down negative 6.32. Okay. Let's do our other intersection point. Now you'll treat it just like you haven't done the intersection. You'll do second trace. Now this part's important that you listen to this part. So now we're going to hit intersect again. Now it's saying first curve. Now notice we're down here close to the first intersection point. If you do it again down here by this intersection point, it's going to just calculate that same intersection point. So you need to scroll with your arrows at least closer to the other intersection point, which is up here, right? Does everybody see that? How I'm scrolling up to be close to the intersection. Yeah? Now it's on the line. I can see that, so I hit enter. Now it's automatically going to go to the other curve. You don't just, your calculator knows to go to the other curve. So hit enter again. And then it says, you want me to guess? You'll hit enter again. And our intersection is at, now look, if you look, it'll also put it in the right spot. Do you see how it's putting it in the right spot? We know we've done it right. So it's intersecting at x is equal to 8.32 and y is equal to 3.32. So I'm going to write that down. 8.32, 3.32. Okay, now understand this though, guys. On an ACT, on my test, think about what we were doing. If we were doing this, we would be solving for x, true? Solving for x. So your answers are going to be just the x values, not the y values, right? So if we were doing this by hand, we'd be solving for x, and we got our x values. So you would write the answer, x is equal to negative 1.32, because that's what we got for x, and then x is equal to 8.32. We were solving for the x where those two things intersect. Now remember, in the original problem, we were solving for x, so we'll just put the x points. Does that make sense, everyone? Okay, awesome. One more, and then I'm going to set you free to practice on your own. One more, stay with me. Here we go. Okay, so here's my next example here. I have this green function, f of x is equal to negative 3x squared minus 4x plus 2. And then I have this second function, g of x is equal to x squared plus 2x minus 5. I went ahead and took the liberty of graphing it really quick, just so I could look at what I'm looking at here. So the blue function, there's not a negative in front, so it's a smiley face because it's positive. So there's my blue line. And then this has a negative in front, so it's going to be flipped upside down, a frowny-faced parabola, because negative people frown. So now notice they intersect in two places. Now guys, when we're solving, if we started with an x squared, we know we're going to have two solutions, true? True? Is that true? Yes. Okay, so you better have two solutions if you have an x squared. Now anyways, we could do this, you guys, I need you to understand this. You could do this by algebra. You could say, okay, I know that the intersection point are where those two functions are equal. You could say, okay, so negative 3x squared minus 4x plus 2 is equal to x squared plus 2x minus 5. Then you could have gone through and done the algebra and combined all like terms and had a quadratic function. We know how to solve quadratic functions, right? Quadratic formula always works, or if it's factorable, it's factorable. Do you understand how you could do it by hand? Okay, awesome. I just want to make sure that you do. Okay, because at times I might say, I want to see you try it by hand on like a test, or we'll practice it though more later. Okay, so I'm pulling up, I'm going to use my calculator really quick. Once again, typing those things in. I hit y equals. Now the reason I'm doing this one is to show you how to change your window, meaning I'm not going to be able to see high enough up or down on this one. So I'm going to type in negative. You can't type in minus 3x squared. Did everybody hear that? It's negative 3x squared. You can't type in minus 3x squared. It's in front, so you have to type in negative, the actual negative, 3. If it ever says error, go back and check. I probably typed it in a negative for a minus or a minus for a negative. So negative 3x squared minus 4x, so minus 4x plus 2. And then what's the one below it? Read it to me. So, oh, plus 2, guys. Sorry. Over. Plus 2 and then down, and we have what's my other function? X squared plus 2x minus 5. Okay. Now I hit graph. Okay, so once again, my window's okay. I can see those two intersection points. But let's say I wanted to see higher up or lower down. Because let's say I couldn't see. Because I did your guys' homework assignment, and I'm like, I haven't changed the window on some of them. I couldn't see where they were intersecting. So I had to change the window. So this is how you'll change the window, guys. Let's just make the window bigger for fun on this one. So notice if I needed to see farther up here, farther down here, or over this way more, or over this way more, you go to your window. X min means how far down on the x-axis you want to see. X max is how far you want to see on the x-axis. Y min is how far down you want to see on the y-axis, and Y max is how far up you want to see. So let's say I wanted to see further down or up. I would scroll down to Y min and max. Now let's say I just wanted to see further down on the y-axis, so Y min. It's at -10. That means we're only going to see as far down as -10. So I'm going to type in -30. Why not? Try it and graph. Does everybody see how now I can see further down on the y-axis? Do you all understand how to do that with your calculator? Okay. Let's calculate the intersection point. So intersect. I did second trace and then intersection. So now it says first curve. I'm going to go over and be close to this intersection point so it knows I want that intersection point. Now I'm on that upside down parabola. I hit enter. It's automatically going to go to the second parabola, so I'm good. I hit enter and enter again. My intersection's at -2.27, and we only need the x value, right? So I'm going to just write that, -2.27, really quick. So we just solved x is equal to -2.27. Let's find the other x value where they intersect, because we're really solving for x here. So now you have to be careful. So second trace, go to intersection again. And now you have to make sure you're close. If you do it right here, guys, it's going to calculate that same intersection point. I'm going to scroll over and get closer to the other intersection point. And now I'm on the upside down parabola, closer to the other intersection point. I hit enter. It'll go to the correct function. When it says second curve, I hit enter again. And I'm on intersection x is equal to 0.77. X is equal to 0.77. So I solved for x, guys. I chose to do it graphically. You could have done it algebraically, and you would have got the same answers. You would have got prettier answers if you would have done it algebraically. But with something like this, I'll take that answer. Okay. Questions on that? Practice it. Do problems 5 through 7. Do not waste any time, because I'm going to bring you back to me quick here. Okay, guys. For this next part. Now, this is more likely something you would see on an ACT, and it is so easy to be ashamed to miss, but it looks really hard. So most of the time students will see this on an ACT, they'll skip it. You're going to see this on our test coming up. I'm also preparing you to be successful in life, so preparing you to take the ACT and do your best. So let's look at what this is asking for, because actually, guys, if we look at this one and read through it, I'm going to tell you it's going to be telling us to just simply find the, find where they intersect. So let's look at this and go through this. So it says, given the volume of a rectangular prism, so this is a rectangular prism, just meaning a 3D rectangle. Does everybody see the 3D rectangle here? A rectangle that isn't 3D would just look like this. This is a 3D, real live pop-up rectangle. Okay, so the volume, meaning if we fill that in with water, guys, listen up. If we fill that in with water, it would equal 80, whatever. 80 cubic inches of water, I don't know. 80, okay? Now it's asking us, what are the dimensions of the length? What are the actual dimensions of the length, the width, and the height? Now, guys, this one is actually quite easy, so don't just say it's a story problem, I can't do it. Because, guys, we're going to see a lot of story problems in this class. Okay, so now, this is something you have to know. I'm telling you, you probably don't know this. To find volume of either a square or a rectangle, if it was flat, it would be length times width, right? To find area of just a rectangle is length times width, right? Now, to find it of a 3D object, you're just going to multiply the width in with that. So area, which would be volume, same thing. So total area would be filling that in, volume already. So volume is equal to the length times the width times the height. Does everybody understand? Let's plug in what we know here. Were we given the volume? Yes, it's what? 80? So 80 is equal to the length times the width times the height. So the length is Is that what you're hoping now? Sorry, I think really hard in this class and I can't think and write all at the same time. Okay, so length, guys. So it's given. We were given that the volume was equal to 8. Good question. So looking at this, guys, what's the length? Hello, what's the length? X minus 3. Okay, so the length is x minus 3. Then we're going to times that to our width. What's our width? Okay, so times by 2x. And then what's our height? X. Now looking at this, we filled in everything. True? So think about it, guys. We want to know where like we multiply this out, which we actually don't have to. We can just type it into our calculator like this. But we want to know where this is equal to 80, right? Where this is equal to 80. Wouldn't that be a true statement to say this is equal to 80? That is our true statement. So let's go ahead and use our graphing calculator to find this. So you're going to have an XY chart on your graphing calculators, guys, and you're going to have a straight line at 80. 80 is still a function. It's just a straight line at 80 on the y-axis. So you're going to have a straight line at 80, guys, and then this, you're going to have some function that looks like this. And does everybody see that they're going to intersect? And that will solve for x, true? Well, that's all for x. We just practiced that. Okay. So let's type this into our calculator. We need to type in these two different functions, though. This is a function. It's a straight line at 80. And then this is x minus 3 times 2x times x. Now, you can just type it into your calculator like that if you want. So you'll go to y equals. Clear those out. So our first function is 80. So I'm going to just type in 80. Numbers are still functions, guys. They're just straight functions, constant functions. And then we had our other equation, which was x minus 3. You got to use parentheses. So x minus 3 times by 2x. So now I'm going to type x. Oh, why is it doing that? X minus 3 times by 2x times by, and I'm going to put this in parentheses so that it knows to multiply all of it times to x. You could put parentheses around all of those things and it would be fine. Okay, questions on that? Now I'm going to hit graph. Now notice, you're like, I don't see a straight line. Look, I don't see a straight line. Well, yeah, you're right, you guys. My window is only going up to 10. And guess what? If there's a straight line, clear up at 80. So I got to change my window to at least see up to 80. Let's go way above it. So my y max has got to be way higher than 80 because we want to see the 80, the straight line at 80. So I'm going to do 90 and then hit graph. Now look, now I can see the straight line. Does everybody see it? Now I can solve for x by finding the intersection. That is where that function equals the other function. So we're solving for x. So you'll do second trace, and then I want to find the intersection. So I hit enter. Now first curve, I'm on this line. So I hit enter. There's only one point of intersection here. My second curve, okay. I hit enter again. Hit enter again. So I get x is equal to 4.76, y is equal to 80. Now it makes sense, y would be equal to 80, whereas high up as 80. So we found our x. Our x is 4.76. So x is equal to 4.76. Well, you guys, x is equal to 4.76. Now, what were we asked to find? The length, the width, and the height, true? Well, now can't we find it since we know what x is? Right here's the length, right? To find the length, we know what x is 4.76. So we'll do 4.76 minus 3. Does that make sense, everybody? To find the actual length. Does everybody understand what I'm doing here? So we get 1.76. The length is 1.76. Now the width here. The width is 2 times x. X is 4.76, so 2 times 4.76. So we know our width is going to be 9.52. There's our width, the actual width, and now the height. Height is x. X is equal to 4.76. We solved for that. So 4.76 is the height. We have solved this. We found the length, the width, and the height. All we had to do was set up an equation and then solve for x. So the one thing you'll have to know is the volume is equal to length times width times height. Okay, do problem number 8. I'll leave this up so you can look at it. I practiced number 8 while that one's fresh. Ready, set, go. So hopefully you were able to practice that, at least start it and continue with that, continuing with that. Okay, so we're gonna, let's skip that. Okay. So now what we're going to be looking at, guys, is different. We're going to be given two functions. One of the functions is going to be given in a table, and one's going to be given in the equation, and it's going to ask you where they intersect. So I just wanted to quickly go over how you do something like this. So given f of x is equal to 2x plus 5, and given g of x is the table below. Now understand, guys, all functions have a table. All functions have a graph. All functions have an equation. So we could go through and we could do this a couple ways. We could figure out the equation from the table. That'd be hard. That'd be hard. Yeah, it would. And then, and we actually will learn that way later in life. We learn that towards the end of the year. Anyways, or we could take this and look at the table. Wouldn't that be easy? Yeah, so let's type that into our calculators quickly. Type it into your calculator. So go to f of y equals. So go to y equals. Make sure you clear out everything. Now we're going to type in 2x plus 5. So type in 2x plus 5. Now, we could either graph it or look at the table. Now, if I graphed it, it's a line. I want the table. So, guys, if you hit the second graph, notice it says table in little writing. That means take me to the table. Well, there's the XY table, guys. Now, if I wanted to see into the negatives, I could do that. I could just scroll up. But now you can see all the values for x and every one of their inputs. So if we put in any of these x's, this is what you'll get for y's. Does that make sense? So these are just a bunch of x, y points. So isn't that cool? Now if I ever say make a table, given this equation, couldn't you just use this? Write it in? Boom, boom, boom. That fast. Okay. Awesome. So now let's look here. Let's look here, guys. Let's see where they're equal. So this is starting at -3. I'm going to go up to -3. So where do our x and y points match up? At -3, -6. It doesn't match up over here, does it? -2, 1. Doesn't match up. That's different. -1, 0. -1, 3. Doesn't match up. 0, 3. 0, 5. Nope, still no. 1 and 6. 1 and 7. Nope. 2 and 9. 2 and 9. So guess what, guys? X is equal to 2. We're solving for x. Are we solving for x or y? Are we solving for x or y? X. So x is equal to 2. So they were the same point at x is equal to 2. So they intersect at x is equal to 2. Woo. Okay. So x is equal to 2. Practice that problem. Number 9. Ready, set, go. Okay, come back to me, guys. Come back to me. Hopefully now you guys you understand how to go ahead and solve equations by where they intersect. So if you're given two different equations, that's where they're equal. So let's say you didn't have a calculator. Set the equations equal, combine all like terms by bringing one thing over to the other side of the equation, and then solving. Okay? If not, use your calculator, see where they intersect. We're solving for x, so you'll use the x point. Okay, now, here we go. Solving for a variable in an equation. So guys, this is a fun fact for you. Most people, okay, if any of you are planning on pre-med or physical therapy or, well, not physical therapy, pre-med, dentistry, pre-law, anything like that. If any of you are planning on doing that, you're going to have to take at least up to calculus 2. Now, fun fact for you. Most people fail calculus 1, not because of calculus, but because of their algebra skills. That is a true fact. Because of their algebra skills, they fail calculus 1, not because of the calculus. Okay, so we're going to be getting really good at algebra in here, because guys, guess what? This class is supposed to prepare you for calculus. Now, so we're going to go ahead and we're going to solve for some variables using algebra. So we're just going to be doing some algebra, and we're going to get some pretty advanced algebra. I'll be honest, but you can do it, okay? So just with solving, guys, you don't need to write this down. Just understand, you have to use the correct algebra, obviously. You can't break any rules. You can't magically float things from one side of the equation to the other. You can't divide things and just pretend like I'm only going to divide half of this. You have to actually do the math and not make any errors. You have to use the correct operation to get from one side of the equation to the other. I already said that. And then you have to remember your inverses. So remember, addition undoes subtraction, right? And then subtraction undoes addition, multiplication undoes division, division undoes multiplication. So I love algebra. I'm an algebra junkie, but then again, I have taken calculus 1, 2, 3, loved it, favorite classes of my life, but those are one of my easiest courses. So just saying, I love algebra. You'll love it too once you get good at it. Okay, so most calculators won't graph something unless it is in the form y is equal to some expression with x. This was on your last assignment, and guess what? 90% of you did. You had x is equal to 3y minus 5, for example, and it said rewrite this in the form y is equal to some expression with x. Now, some of you said, okay, no, 90% of you said, all right, then I'll switch X and Y. And you switched X and Y and just reorder like that. You pulled the old switcheroony. You can't do that. You can't just switch them. You can't just switcheroony. You've got to do the math. So this is our first example. Here we go. What are we trying to solve for? Essentially, we're trying to solve for Y. We want to have our Y all by itself. Does everybody understand that? So let's do the algebra to get Y by itself. Not just switch them. That's wrong. Not correct. Okay? So to get Y alone, what's my first step? Add 5 to both sides. So on the left, I have X plus 5. Now if you'll just rewrite them, you're going to save yourself a lot of errors. X plus 5 is equal to 3Y. Does everybody see what I did there? Please ask if you don't. What am I going to do to get Y alone? You divide it because you were multiplying. Well, undoes multiplication division, so you divide both sides. You have to do both sides by 3. So then over here on the left, I have X plus 5 all over 3 is equal to, and then they divide out and we get Y. Is Y all by itself? We've reached our goal and we're done. We did the algebra behind it. Let's do another one. I even color-coded it because we're going to get into some difficult ones. Okay, so here we go, guys. Stay with me, please. It says rewrite the equation to solve for X. Now this time we're solving for X. So piece by piece, we're trying to get X alone. Piece by piece, we're trying to get X alone. I color-coded it for you. So if you're ever solving for a variable, guys, focus on that variable and piece by piece, in the correct way, get it all by itself. What's my first step? Good. Add 2Y to both sides. That has to be my first step with this one. So I have 4X is equal to, those added up to be 0, so we got rid of it. And then we have 2Y, positive 2Y, so I'm just going to write 2Y, and then it's minus 7. Can you combine 2Y minus 7? Not like terms. Very good. Next step to get X alone, what am I going to do? 4 was multiplied to X, so what will we do? Divide by 4. Divide both sides by 4. All right, so we have X is equal to 2Y minus 7 over 4. We have now solved for X. We've reached our goal, but using the correct algebra. Makes sense? We're going to get more advanced and more advanced here. Stay with me. Don't yawn, that makes me cry. This is like really fun. Here we go. Solve for A in the equation. B is equal to A squared plus 10. B is equal to A squared plus 10. Now you have to do this in the correct algebraic order. G. A is what we're solving for. A is what we're solving for. We're trying to get A alone piece by piece. Did everybody hear me? Trying to get A alone piece by piece. What is my first step? Minus 10 from both sides. Good. Was that little Jessie A? Thank you. So B minus 10 is equal to A squared. Yeah? Now, how do you undo A squared? It's not A, guys. Square root. Square root undoes the square. So we'll take the square root of both sides. Now, when we take the square root and we're solving for something, we have to account for the what? Plus and minus. Good. That's what I was looking for. Good. And we have to do it to both sides. What you said is true as well. So look, guys, our root cancels out with our power. We took the square root of both sides. We won't forget our plus and minus. So when we're solving, we have to account for the plus and minus. So now we have A is equal to, because A was all by itself, I'm just writing it in a prettier order. And then we have plus and minus the square root of B minus 10. That's our final answer. A is now by itself, and we're done. Does everybody see that I just put the A on this side now? Ding, ding, ding. Do you get that? Okay. Couple more. Never mind. Do problem 10. That's where we'll finish. So do problem 10, the whole front sheet. We'll have to spend a day on the back, unfortunately. Oh, yeah. Really, though, you should be able to do 17 and 18. Those are review problems.